Hello everyone. Next we'll discuss selection of circuit breaker of your second module, unsymmetrical faults. So we'll be having one basic common sense, common question. So why the video framed the syllabus, the selection of circuit breaker at the end of the second module? Because see, we have discussed transient of transmission lines, we have discussed subtransient analysis, steady state analysis, and then fault analysis in the transmission lines. So after the fault, what happens? There is a safety. So if suppose fault exceeded some limit, if the number of cycles increases, time will be increases, what happens? Automatically the equipment will damage, or the working person will get more effect. So that's why they kept a syllabus at the end of the module, selection of circuit breaker. So the name itself indicates the circuit, the name itself indicates circuit breaker which breaks the circuit when fault occurs. Even though the power system components and power system analysis subjects will be having throughout the safety devices. So for example, I'll be discussing in our home also, if you're operating any electrical appliances, if you're operating any electrical components, if the unknowingly fault occurs, without knowingly you have done a mistakes, what happens? Automatically that fuse will get melt, as well as the MCB will get trip off. Is it right? So even though the present manufacturer, we want some present, right? So even though the present manufacturer, while manufacturing the electrical appliances, they're having two safety devices. One is fuse as well as MCB, because they are giving 2 years, 3 years warranty for the components, electrical appliances, because they'll be having two safety devices back to back, because to satisfy the customer. If suppose fault occurs, if suppose anything happens, automatically they will change the MCB, or they'll change the fuses. So suppose you are working with a mixer grinder, or you can take washing machine or whatever. So if suppose two wires will touch, phase to neutral or whatever happened, what happens? Automatically the current exceeded the limit, automatically the circuit breaker will trip off, again will reuse, and then otherwise will try to solve the problem, and after that will be reusing the components, right? Okay. So next, so the basic common sense. So in the electrical appliances we have two components, fuse and MCB. So in this module we have a circuit breaker. So how exactly circuit breaker operates, we'll see to it. Okay. So suppose I'll be considering one bus bar. Okay, bus bar. I'll just consider one bus bar over here. So you can see this bus bar nearby your home. There is a H-pole mounted substation will be available there. The person will be operating, electrician will operating, they will be changing the lines there where they are having one MCB, one bus bar. From there I'll take one just black diagram. Okay, black diagram. So this is the transmission lines. Just I'll take a single phase transmission lines. Single phase transmission. This is just one pole will be there, just to assume. Okay, here there is a plunger, or this one. This part is CB. So here we are having CTs. Okay, CT, and then there is a relay will be there, and then this is relay. Okay, relay component. So these are transmission lines we are using in the power system components. So okay, so if suppose fault occurs in the transmission lines, what happens? If suppose fault occurs in the transmission lines, automatically the CT will sense the fault. If suppose CT, how exactly will operate? If suppose current exceeded the limit, if suppose 2 amps will be there, if suppose 2.5 amps occurs, automatically that CT will energize, and then that high current will be sensed by this relay. This relay will sense. This relay will send the signal to the circuit breaker. This circuit breaker. So initially this is a closed position. Okay, closed position. Automatically this will open. Automatically it will be open. Likewise it will be operating. So again I'm explaining, revising. This is a circuit breaker, this is a relay, and this is CTs, and then this is a fault, just one fault, and tree is falling on the transmission lines. So CT and PT we are using current transformer and potential transformer in the transmission lanes because of to measure the high current and high voltage. Just keep it in your mind. When the fault occurs, automatically CT will sense that current, the coil get energized. That energized coil, whatever the current exceeded, that relay will be sensing. That relay will send the signal to the circuit breaker. Automatically this contact will open. This is the overall working of your circuit breaker. Okay. So I think you might be having some idea how exactly they will select the circuit breaker based on current. It will be there, and then based on voltage, based on circuit breaker operation. So moment of this one circuit breaker operation. See one basic question, basic concepts. So we need to eliminate whatever the fault in 0 to 3 cycles. So if suppose this cycles exceeded, so automatically that equipment will damage, or person who is working that appliance or component will get some severe shock. So the most dangerous fault is triple L fault, and then triple LG fault. You should eliminate within 0 to 3 cycles. Otherwise the whole system will damage, or otherwise everything will vanish. It will get melt. So how exactly so I think circuit breaker, how exactly selection of the circuit breaker, we have to read the how exactly circuit breaker operates, and it is must for to isolate from the healthy part immediately on the occurrence of the fault. So to make a healthy, so we are having a safety devices, and the particular application depends on the following ratings of circuit breaker: normal working power level, and then the fault specified either rated short circuit or interrupted current on the short circuit MEA and megavolt ampere, and the momentary current rating, and the normal working voltage, and the speed of the circuit breaker is very much important first to select the circuit breaker. So next we have how exactly the circuit breaker will select based on the multiplication factor. If suppose 8 cycle will be there, this cycle will be 8, so the multiplication factor is 1. If suppose 3 cycles, the multiplication factor is 1.2. If there is a 5 cycle, 1.1, and then 2 cycles, 1.4. At the this will the fault will be clearing as soon as possible. If suppose fault if you take 1 minute, so whole system will damage, the person definitely he will be it dies out. So that's why, so it must be 0 to 3 cycle. We should have a basic common sense, basic knowledge. So it will be eliminating so based on the cycles: 3 cycle, 2 cycle, 5 cycle, 8 cycle, whatever it may be, it will be operating. So CB is circuit breaker based on the fault cycles: 8 cycle, 5 cycles, 3 cycle. So we are using multiplication factors, just to keep it in our mind. Okay.